Good afternoon, everybody. Welcome. You are in the right place if you're here for a NEWCOM and Neverfail webinar. This is part 2 of our webinar series. I am Jim Carmen, Director of Sales for NEWCOM. With us today, we have Michael Wrightson, GM for Neverfail. We're going to go over part 2 of our webinar series, which is enabling automated recovery, how to recover critical public safety systems instantly, regardless of incapacitated or limited staff. Michael has prepared an exceptional bit of content for us. We are recording this session, so we'll be able to send out the recording afterwards. If you missed part 1, we have that recorded and on our website, newcomglobal.com. And then part 3 is coming up in just a few weeks. We're going to do that on June 11th at 1 o'clock Eastern. During this call, feel free, ask any questions, raise your hands, type your questions in the chat box, and we will get those addressed. And then we'll leave time after Michael performs a demo to answer any of your questions directly as well. So without further ado, Michael, I'll turn it over to you.
Thank you, Jim. Thank you. As mentioned, my name is Michael Wrightson. My friends call me Mike. I am the general manager over at Neverfail Continuous Availability. I've been with the company for in many different roles, if you will, for about 10 years now. Started as an SE and then kind of worked up my way into product management. Eventually, I took over all of product management, and now I've been just recently was appointed general manager. So I've had a pretty extensive, experience in continuity over the years, and this wasn't my first stint. Actually, I worked for another company many years ago in continuity. So what we're going to do is we're going to talk a little bit about how we can prepare for and avoid catastrophic disruptions. So this is part 2 of the webinar series that is entitled "Enable Automated Recovery: Instant recovery of public safety systems." So we actually have, as mentioned, the third one on June 11th that will go into more in depth how you would protect your environment against cyber attacks and system failures. But for today, let's talk a little bit about how you can protect your systems today and make sure that they are fully operational in the event of a loss of your production environment. Right now, as we know, we're really we're in the middle of a global pandemic, and a lot of people, unfortunately, we've lost a lot of people along the way. But what's interesting too is in the last few months, is we've and certainly from a Neverfail perspective, we've talked to a lot of our customers and partners, and we're seeing that a lot of our customers have become more aware that not only do they need to prepare for the natural or man-made disaster, but also now they've realized that they could potentially lose their staffs due to sickness during a pandemic, which could, even with the best, a lot of technology that has been implemented in the environment, this could be a serious risk to them. So today, what we're going to do is we're going to focus in on how we can use and leverage automation to help you during these times of pandemics, right? So to really reduce the risk that you have to your staff. So to get started here, there's a couple of different things that we're going to talk about. So the first thing is we want to introduce you to what high availability is and what it is, right? So we're going to talk extensively about that for the next 20-25 minutes or whatever. And then we're going to, that will set the stage for us to talk about the challenges of how you get to instant recovery. So that is really the goal of this entire exercise today in this webinar, is to really help you to understand how you're going to get to fully automated recovery and understanding the complexities that go into this. And then finally, we're going to talk about how that recovery could be implemented in the considerations that you need in order for you to build a fully automated approach to business continuity and disaster recovery. And then what we're going to do is we're going to take all of those fundamental concepts that we've just discussed, and we're going to show you how it could be implemented in real time in your environment to provide you with the ability to have intelligent failover that's automated in a local environment in case your teams are incapacitated. So let's get started. So one of the things that we want to kind of start with is the understanding of what high availability is and what it's not. So, you know, just to start with a common definition, so it kind of lays the baseline for the entire conversation today. You know, high availability literally refers to systems that are durable and likely to operate continuously without fail as long for a very long period of time. And in these terms, it implies that part of the systems have been fully tested, and in many cases, they are they have accommodations for the failure events and a form of redundancy that can help them to recover. So, for the purposes of this conversation today, we are going to talk about and concentrate on how we can reduce downtime for critical business systems. So when we talk about high availability, there are two different types of high availability. There is what we call redundancy, and then there's also fault tolerance, right? So with redundancy alone cannot really ensure you of high availability. A system also needs to have failure detectability mechanisms like hardware and OS and application awareness. So simply having another just standby server there that is configured with the application doesn't really cover you in all the different aspects, right? So you still have to understand what's happening at the application layer. You still have to have some type of insight to what's happening at the OS layer. So it's more than just having standby hardware. What about fault tolerance? Well, fault tolerance is a very common technology that's out there. And a lot of people associate that with high availability, but even then, high availability implemented as fault tolerance has its limitations. So although both of them refer to techniques for delivering high levels of uptime, fault tolerance, versus high availability strategies achieve the goal differently. So from a fault tolerance perspective, it really depends on the computing requirements for redundancy in the hardware. So multiple systems operate in tandem to achieve fault tolerance. Identical systems in mirroring applications and executing instructions together all kind of combine into this model of fault tolerance. So when you look at this, though, there's still the same shortcomings with this. When you detect the hardware mechanisms, you still don't see anything that's happening at the application, at the OS level. So fault tolerance doesn't solve all the problems. It's just essentially hardware redundancy, right? But maybe a little bit more intelligent than it would be for standard redundancy, right? So these are this is the two areas of high availability that are the most widely used today. So what are the main causes of downtime? Well, redundancy only covers you from virtual or physical hardware failure, and it does not address the broader issues that could affect the delivery of the application service. In fact, Gartner has stated many times that 80% of failures come at the application layer. So hardware today is extremely reliable, and yet people focus on this and spend a lot of money on hardware, to reduce the risk of hardware failure, and yet the majority of the incidences are actually at the application. So what we're going to do is this is our slide number 3, right? I want you to kind of keep this in mind as we go through the rest of this presentation. So when you're looking at downtime, there are many things besides the hardware that could potentially take down the business services. We're talking about human error. We're talking about application and maintenance of the application server, the software itself, right, that we're providing redundancy for. The security, security aspects of this, maybe cyber attacks could be an issue that could essentially bring on a failure of the system. Of course, hardware failure that we've talked about, right? But also man-made and natural disasters, including pandemics, right? So these are all causes for failures. So as we go through the rest of this presentation, I want you just to keep these 6 points in mind. So what is the challenges to get to instant recovery? So this is really one of the key slides in this entire presentation, because a lot of times we don't really understand what's happening under the covers. So, and it's because it tells a narrative of why it is hard to produce reliable failover with advanced and intelligent continuous availability tools, right? So if you look at what we're going to consider later on, and remember the first slide or that last slide that we just examined that talks about the failure events that could potentially happen. Now let's actually look inside the application server itself and look at the complexity of its components in order for you to have this instant recovery and orchestration model. So it all begins with a single server, right? So you have a physical or virtual machine, and you have a single application service, right, that provides you with the application that you're working with. So in this case, you have it's simple when you look at it, but underneath you still have the complexity of ensuring that the OS is operational and is accessible to the end users, right? So even though you only have one service to deal with that you have to restart or you have to ensure is up and operational, you still have other dependencies that are part of the operating system that could possibly go wrong. This is actually the simplest of all the models that we're going to talk about. But even here, you can see where there are dependencies between the operating system and the availability of the application itself, even with a single service that's running. So now let's kind of take it up one level. So now you have a single application server that has multiple application services that are running, right? And interdependent services, including, even things that are stored on the disk and other maybe dependent applications within that server. So, for example, maybe in a CAD application, you may have the CAD software. There may be, there's going to be some type of web components to this. There will also be, database. All these different things are actually services that are running on that individual server. So now you have additional complexities that you have to deal with, right? So now you have multiple dependent services, and now you have to track which services need to be started and in what order. So, and you also have to consider the dependencies between that and the operating system. So there's a lot of things that you can do. And we actually had some customers try to say, well, we could script all this stuff. Literally, it takes years of experience to try to really sew all of these things together to make them make them reliable, right? So again, we're talking about a single server with multiple services on them that are all dependent on one another. So now we're going to take it up another level, right? So now we're going to take it to the application farm viewpoint, right? So now we have multiple servers that have multiple services on it, and they're all in each application server is dependent on the other, right? So you have your database server, your application server, and your web-facing servers, right? All of these are dependent on one another, and they all have their own complexities of their own services within that. So you can now see the challenges that it takes to really orchestrate these failover processes, right? And be able to get to instant recovery. You're going to need a technology that has been doing this for a long time and has concentrated on these workflows to be able to do these recoveries very, very reliably. So this is a very critical piece to understand as what's happening under the covers, if you will, for your applications. So since we now know the complexities of these, let's take a look a little bit about some statistics, right? So if your application or your application farm, sometimes also sometimes people refer to it an application farm as a multi-tier application. The effect of that could be staggering, right? So a single server being down could cost as much as $50,000 an hour to you as an end user, right, or your organization. But then once you start pulling in an application farm configuration, this literally could go up into the $100,000, $200,000 range. So I'm going to give you a real life example of what we at Neverfail, a customer of ours, ran into. So about, I don't know, 6-7 years ago, I was working with a company, and this was actually just maybe a couple of years after I came on. It might have been like maybe it was about 8 years now. But one of the companies we worked for was a not-for-profit research firm in Washington, D.C. And they got a lot of their funding from corporate and other sponsors. And so they had this website that it was kind of like their extranet application. And so what they did was every day they took in about $70,000 a day in donations from corporations and other support groups. Well, it just happened that this system went down. They lost the hardware went bad. I think they had a full failure of the drive system. It cremated all of their data on the server, and so they had to literally replace the server. That one event cost them 3 days of downtime on an average of $70,000 a day. So we can see how important it is to have the right approach to high availability, right? So, and then, if you look at, we looked at some other statistics here. I think one is really compelling that less than 10% of organizations that don't have this comprehensive plan to recover can even survive this, right? So if you think about if these guys were down for 5, 6, 7 days, right, or a week or so, and they couldn't get their new hardware in, the losses would have been staggering. So this is really what the problem that we see today is, just understanding the complexities, what causes downtime, and what's really the real cost of failure is to your organization. So one of the other things that you're going to probably hear, and you probably have already heard, is when people reference system availability and hardware availability, what does that really mean? Well, when you look at what these two areas of availability look like, let's take a look. Let's consider what system availability is, right? So this is literally, it focuses on the uptime and delivery of application services via replication technologies, right? So this literally is, I have an application server and its farm or its farm, and I have technology that replicates this to some standby server, right? So you have. So a system availability is the measurement of that, right? The uptime and the delivery of those application services. Hardware availability is strictly that. It's looking at the components of physical hardware systems. So this is, your RAID configuration on your disks for your servers, how the memory is configured, do you have redundant power supplies or not, things like this, right? So those are what we consider to be the underlying hardware availability, where the system availability is really about the application itself and how we're actually protecting it. So now this kind of brings us to how all this kind of fits together, right? So when you look at different technologies out there, and we kind of talked a little bit about this on if you saw the last presentation, the last webinar, we talked a little bit about this, but this is kind of how it all comes together. So you have these different types of protection technologies that really kind of stack up into three areas: continuous availability, hardware focused, and data focused technologies. So let's take a look at the data focused technologies first. The bottom end, and these typically are backup technologies that exist today. They've existed for the last 20 years. But the idea here is that they back up data, whether it is, databases, file systems, virtual machines, whatever it may be, but it looks at them from a data perspective, right? So usually these are very low cost technologies. They have, low RTOs, recovery times, but they have variable RPOs. So you can have sometimes you can get the data back quickly, but there's time, if you will. If you remember back to our last presentation, the Rpo and Rto comparison, the RTO is your recovery time objective, and the Rpo is your recovery point. So our recovery time is how fast it takes you to restore that information and get back up and running. The Rpo is how much time or data you can lose within a certain amount of time. So most of the technologies that are out there do things like snapshots and asynchronous replication, but they could have variable length RPOs. So these are data focused and don't really protect you from all of the potential things that could happen to your application. Okay, and then so the next one is what we call hardware-focused technologies, for HA, right? So these are typically clustering technologies, like a Microsoft failover cluster. When you look at hypervisors, these are VMware HA or the equivalent on other platforms, or fault tolerance technologies. So all of these kind of give you a very high cost of entry, but they have very high RPOs and RTOs, right? So this is a technology, but that gives you improved performance, but it still doesn't cover all of the areas that could potentially take out your business service. Remember that slide number 4 that we talked about, right? All of the different areas that could potentially take out your business services. So those are what drives these type of technologies. So where you really want to be is at the top of the funnel, right? You want to be what we call continuous availability. So continuous availability gives you a low cost of entry, but it gives you the highest levels and lowest RPOs and RTOs that are available on the market, right? So the idea here is once you add the real orchestration and application-aware failover to this, then that changes the game on here, right? So now you can actually see all of those different events that are happening, whether they're human errors, they're application or software problems, they're networking issues, they're operating system problems, hardware failures. All of these things now are laid bare when you have application awareness. So this is what continuous availability brings to the table. And this is really what you want to get to. So I would say you still need to do your backups. Everybody still needs these types of technologies. You still need to be able to do, archival and, other types of backups. When you're looking at the tiering of your backup or your recovery, typically it goes from like a 0 to a 4, right? 0 meaning the top, giving you recoverabilities of seconds to just a minute or two. And if you're on the last presentation, we actually had a really great slide that talked about this. And then it goes to tier 4, which is like an archival type of backup. But what's interesting is that when you get into tier 3, 2 through 4, these are typically backup solutions. Tier 2 is usually like a clustering type of solution. Tier 1 is continuous availability, or tier 0, I should say, is continuous availability. So these are what you need to kind of help put these types of protections in place. So best practices would be to have, of course, you got to have your backups in place. You still need to protect your data, right? You still need to have some type of clustering technology, some redundancy, if you will, right? To ensure that you have recoverability. In some cases, you might even look at things like network load balancing to help with these, right? You need a good failover solution that can do the orchestration model, and you need continuous availability in order for you to see all of the different things that are happening out there and be able to react to them in a very timely manner, to automate, if you will, and orchestrate that failover process. So all of these come together to be able to provide you with the core services that you need to keep your application running. All right, so let's talk a little bit about failover orchestration. So up until now, we've really talked about what could take out those services. And we talked about the complexity of the applications. We also talked about a little bit about some of the things that, that you need to consider, right? So now let's talk about when you're selecting an HA type of solution. So now let's talk a little bit more about, we're going to go a little bit deeper now into the orchestration model. So in order for you to get to a very fast recovery, you need to understand where, what are the components of an orchestration process. So we start out with the complexity of the application. So each application is unique in terms of data, services, and performance. So when you think about an application, remember going back to that slide that shows a single server, single service, single server, multiple services, and then the application farm configuration? Well, understanding that is going to, it will help you to understand how you need to recover that entire business service. So complexity of applications is essential. The next one is really understanding the security context. So ensuring that whatever process that you have in place, that you or the protection technology, that it takes into consideration permissions that when you stand up a new passive node to fail over, all those permissions are there, so that when you fail over, the users can get access to that system, and also the system can talk to other applications and have the right permissions to do so. So understanding the security context is also a critical piece of orchestration. The third component is anticipating failure events, right? So what happens when the disaster strikes, right? So we need to make sure that we have insights to what's happening at the application layer and the application stack, as we talked about, maybe even the farm configuration, networking, hardware, operating system, the application performance, if you will, and its accessibility, including its core services. All of these have to be monitored real time in order for you to get to where you need to be, right? So get that orchestration model. So all of these have to be anticipated. And then finally is addressing the single points of failure. So this is an area in which a lot of people sometimes don't consider. So these are things like ensuring that your nodes are isolated. So if something happens to your production system, it doesn't affect those passive nodes. So, you could, and with some of the clustering technologies that are out there, because of the way they're designed, if, something hits the production server, it can take down the entire cluster. That's what you do not want to happen. You also want to have a technology that is a shared nothing architecture. So storage could also become a single point of failure, right? And then, you also want to make sure that the underlying networking and all that stuff is all redundant. So those don't become a single point of failure. So with typically, when we do a continuity engine deployment at Neverfail, we always try to encourage our customers to make sure that they're on, the primary and their secondaries are on separate storage systems, on separate hosts if they're virtual machines, just in case something happens, right, to the backend system. So it renders your cluster inert, if you will, right? So So managing and understanding single points of failures are critical to orchestration, reliable orchestration. Okay, so how does this all come together? Well, in order for you to have a fully orchestrated model that gives you the resiliency that you need to be able to see the incidents coming, right? So application awareness is critical to this process. So you need to have insights to the performance of the application accessibility, the networking that's under it, also the resources that are available to that server. So having this available is key to making sure that this all comes together. Application awareness is everything with HA. So getting that, understanding all of those, remember going back to slide number 4, right? All of those different things that could potentially happen to that application are driven and are exposed via application awareness. So any tool that you put into place has to have this, or it's just not going to give you what you need. Okay, so what have we learned so far? So we've learned what HA is. We've also learned where, what could potentially happen to your applications as far as the types of outage events. We've talked about a little bit of how the orchestration process should work, where your points of failure could potentially be, what the definitions of different types of HA strategies are, right? And now we've just talked about the importance of having this continuous availability model with application awareness, how important that is to your overall HA solution. So Continuity Engine addresses all of these associated with the failover and orchestration and application aware failover, also provides users with the highest level of protection that can be available today. So this is, now what we're going to do is we're going to show you this in practical terms, right? So let me switch to my environment. Okay. And Jim, can you see the environment?
Yes, sir.
Okay. So what we want to do now is kind of bring this entire narrative together, right? So when you select a technology, you want it to be able to recover from an event without a lot of people having to be involved, right? So ideally, you want the whole process to be fully orchestrated with intelligence that just does it. So coming back to our key narrative for the entire presentation, we're talking about a process that can automatically fail you over to a server if your team is incapacitated, right? You don't have to have people there necessarily to push the buttons. And if you do have somebody there, you can have somebody who is not, a real IT guy that has huge, knowledge of your infrastructure to be able to power this to happen, right? So what we're going to do now is we're going to show you a demonstration of a simple use case where Continuity Engine can recover from a service failure. So this is what you're looking at is a tertiary deployment of Continuity Engine where we have HA and a third copy at a different data center for our DR. Now, what we're going to do is, since this is an HA deployment, the first two at the top are sitting in our Austin data center. This is our HA pair. With Continuity Engine, we have what is considered to be a clone-based architecture. We talked a little bit about this in the first presentation, but essentially what we do is we take a snapshot copy of your production server, so we have an exact clone of it, and then we kind of bind them together so that the primary can replicate its data over to this passive node that is an exact clone that is offline, right? So at the time of failover, we actually assign the same IP address. It has the same name, the same security context that we talked about a little while ago. All the things that we saw in the previous slide that powers all of these things, such as application awareness, having the security context, understanding, all the points of failure. All of these are considered when you go with a continuity engine deployment for HA, right? So let's take a look at the services that we're monitoring. So this is a SQL 2012 server, and here Continuity Engine is actually monitoring all of the core services for SQL Server. So if I go into edit on the SQL Server agent, for the purposes of this demonstration, we're going to have it, when we actually simulate the failure of that service, we're going to have it do an automatic switch over to our passive node to restore this business service or the SQL server. Continuity Engine is variable in the fact that it can do multiple different types of recovery actions. So when a service fails, we can switch over, we can restart the application, we can restart the actual service itself if it dies, and in a VMware environment, we can even do vMotion as a recovery action, if you will. But nonetheless, in this demonstration, we're just going to show you how fast Continuity Engine can react to these types of outages. So what I'm going to do is I'm bringing up my SQL Management Studio, and I'm going to actually create a new database. I'm going to call this NEWCOM. So I have a new database. I have Sue's here. I have Lou's. So we have data that we've already created. Databases. Actually, I'm going to go and delete this guy too. So I want to kind of demonstrate as part of this how fast the replication process is. So watch this. All right. So what you're seeing now is that if I go back to the server screen here, I have an ongoing ping that's pinging the server at 0.27, and that is our primary server, which is our active node. So now what I'm going to do is I'm going to go in to the server, and I'm going to simulate a failure of the core service, in this case, the agent service. So as we talked about, Continuity Engine is always monitoring the application, the hardware, the operating system. It's also monitoring different types of things within the application, its performance, and also the networking and even the core services, right? So there's in the background, Continuity Engine is rolling through these different rule sets, and every, say, 20, 30 seconds or so, it does a check to see if everything is there. And in a moment, you're going to see that Continuity Engine is going to say, oh, wait a minute, this is not here. And I need to react to this, right? And then what it does is it goes through those rules that we just showed you in the last diagram, and then it goes through and it triggers this failover event. So sometimes it takes about 30 to 40 seconds for it to kick in because it's actually going through a whole bunch of these monitoring tasks at a time. But now you can see that it saw that the services were offline and it executed that trigger, right? So now we're into a recovery action where we're bringing the secondary server back online. So this is the process, and it actually tells you all of the stuff that it's going through. So the services are down. It says, okay, I need to switch over to my secondary to restore the business services. It will then hide the primary server from the network to take it offline. And then it transitions over to the secondary server. It assigns the same IP address, spins up the services for that application. And then it reveals it, and then it actually becomes active, and it will show you that even the replication has been reversed. So once this is done, you now have a secondary server that is active. But notice in a tertiary deployment where we have a 3-node configuration, the secondary does not stop replicating over to the DR sites, right? So you have an active secondary that's going all the way over still to our DR site. So you even have protections from a loss of your primary server, you recover to your secondary, and if you have a trio configuration, you still have your DR accessible and is still replicating. So it looks kind of like this when it's done. So now I have the secondary on up and running, and I can just create a new database. It's created on the secondary. It has the same IP address as the primary. Nothing has changed. The end users just see a momentary blip of delivery of the service, and boom, it's automatically back online again. In fact, as you can see here, it's still pinging at 0.27, and nothing happened. If I roll back a little bit here, you'll see a 2-ping outage, if you will. That was the moment that it actually switched between the different nodes in the cluster. So as soon as that happens, boom, the secondary starts replying on 0.27, and everything is good, right? So this is the power, guys, of Continuity Engine. This is the technology that provides, go back to that one slide that talks about the evolution, right? It's that continuous availability level where we can see, based on this application awareness, when certain things happen. Like we have this case in this basic demonstration, it was just a simple service failure, right? But we also can detect network outages and blue screens of death and all these other things that could potentially happen to your production server. So now this kind of paints the narrative, right? You have a technology, Neverfail continuous availability, powered by a continuity engine, and this technology is designed for critical applications such as CAD applications for public, for the public government agencies, and for emergency response and things like jail management systems and records management. But again, this technology can scale to any application that runs on Windows, and it could be really designed for any type of critical application in your organization. So with that in mind, I think we've concluded our part of this, and let me kind of switch back here. There we go. And with that in mind, I will turn this back over to Jim.
All right, thank you, Mike. Such a powerful tool. I can't see a public safety agency managing applications without Neverfail. Just so much risk. I have no questions in the queue. Do I have any questions from our attendees? Anything that you guys want to know? We can address those now, or you can send those to us as well. sales@newcomglobal.com, and we will get you a response. I think you just covered the information so well, Mike, that we don't have any questions. But I want to thank everybody for the time. Yes, good.
No, I was going to say, if you do, the NEWCOM team is here. They're very experienced with our technology. And if they don't have the answers, they know who to go to get it. So
That's
they
right.
They always have us in the background here. They can ask.
Well, everybody, I want to thank you all for your time, for joining us. We sincerely appreciate your support and your attendance today. This session's been recorded. We'll be sending it out to everybody, as well as an invitation to join us for part 3 as we conclude the webinar series. Part 3 will be on June 11th. Avoid catastrophic disruption and protecting your critical public safety systems from cyber attacks and system failures. So you won't want to miss that. That being said, thank you all for joining us, and until next time.